We're doing 7.3 vectors in a plane, and this is day 3. Okay, Mr. Dunn.
All right, the essential question for today is how do I write vectors as a linear combination of unit vectors and perform operations with them? Okay, so first off, we are going to start off by writing in standard unit vectors, and you need to know what they are. So jot all of this down as I go ahead and explain it.
What's up, baby?
Basically, I and j will represent our standard unit vectors. I will represent a horizontal unit vector, so the one going along the x-axis, and j will represent the unit vector along the y-axis, so the vertical one. Now, in terms of any general vector, we can always write them using the standard unit vectors. So, for the past day, we've been working with something called the component form. And that's where we wrote it kind of like a coordinate point, except using this notation instead. What I've showed here is kind of how they split it up. We turn this component form into two addition problems, or an addition problem using two different components. And then we factor out the two vectors, which we're going to call scalars now. And that is in the book, and I will show that in just a moment. But once you factor out the scalars, we notice that we end up with a unit vector, 1, 0, and 0, 1. We're going to call these unit vectors using I and j throughout our problems. Okay, so this right here is the linear combination. And that's how we're going to be representing all of our answers in today's examples. So make sure that you're incorporating I and j into it, okay? So as I mentioned, we are going to be using scalars in here. So V1 and V2 become the scalars for the horizontal and vertical components of the vector V, okay? And that's pretty much everything that I just mentioned. Let's go ahead then move into example 1. Example 1, we're going to find a unit vector in the direction of the given vector. We're going to go ahead and start off with this problem.
Shut up.
So the vector v is equal to 3, negative 4. So the vector v is 3, negative 4, and we need to find a unit vector in the direction of the given vector. In other words, we want to write it in a linear combination form. Okay? So what's going to happen here is that we're going to have to first off rewrite this using these guys. Okay? So let's go ahead and factor it out. So here, we're going to have 3, 0. Actually, hold on. Sorry.
What's up, baby?
Thank you, Jimmy.
Dude,
so
just go.
It actually already started off with 4i minus 3j. So we're actually starting with a problem that is in linear combination form. And we're going to rewrite it in component form in order to help us kind of solve this a little better. So we're going to replace I, first off, the horizontal unit vector, with the component 1, 0. That's going to be minus 3 times the vertical unit, so that's 0, 1. From there, we're going to go ahead and distribute. We get 4, 0 minus 0, 3. And the component form of this vector will be 4, 3. So with that, we can go ahead and find the magnitude. So the magnitude of v will be the square root 4 squared minus 3 squared, or actually plus 3 squared, equals 16 plus 9 square root of 25, and that's going to be 5.
Good job.
Okay. Now from there, we are going to divide this entire component form by 5, so everything becomes over 5, 4 over 5, 3 over 5. And then I want to go ahead and write this in the linear combination form. So that's going to look like this. V equals 4/5 I minus 3/5 J. Okay? Basically the same vector, just a different way of writing it out. Okay? From there, we're going to go ahead and move now into example 2. Using the initial and terminal points, we're going to write the vectors as a linear combination of the standard unit vectors I and j. In other words, you're going to be given an initial and terminal, and from there, we solve it. So let's go with an initial of -3, 1, and a terminal of 4, 5. Okay, so same thing we've done yesterday. 4 minus -3, 5 minus 1. It's going to be 7, 4. And then writing that as a linear combination, that's going to be 7i plus 4j. Okay? That's basically the idea of working with linear combinations. It's practically identical as a component form. We're just writing it as a expression rather than a set of points. So that's going to be it, and you're going to apply that into several sets of problems tomorrow. So go ahead and write down any questions you have. Otherwise, have a good day.
Wait.